All right, so let's look over the questions on the first checkpoint. I'll kind of walk you through the way one way to address them. Doesn't have to be the way you did it. So we're told this function f of x equals 2x minus 7, and we want to find the average rate of change over a certain interval. So part A, so how do I find an average rate of change? So the average rate of change on a function, I'll give you the formula you probably got from the module or from the notes. So what is the right end of our interval? So our interval goes from x equals 4 to x equals 10. So I'm going to do f of 10 minus f of 4 over 10 minus 4. So what is f of 10? If I plug in 10 for x, I get 20 minus 7, that's 13. Minus, all right, now I want to plug in 4. 2 times 4 is 8, minus 7, that's 1. So 13 minus 1 over 6. 12 over 6, I get an average rate of change of 2. So that's the average rate of change over that interval. Average rate of change on another interval. So same function, we just want to handle a different interval this time. So you may already be ahead of me on this, but I will go ahead and calculate it anyway. So what is f of 6 minus f of negative 2 over 6 minus negative 2? So if I plug in 6, I get 12 minus 7, which is 5. If I plug in negative 2, I get negative 4 minus 7, which is negative 11. So 5 minus negative 11 over 8. That comes out to 16 over 8, which is 2. So for that part of the question, I said either make a calculation or explain how you know. So I get the same answer as I do for part A and for part B. So is that a coincidence, or why does that happen? So the function we are given is f of x equals 2x minus 7. If you were to graph that, think about what it would look like. That's a straight line. So if we have a straight line, I'm going to try to graph that. If it's not super accurate, that's okay. I just want to illustrate something. 2x minus 7. So crosses the y-axis about negative 7. Has a slope of 2. So let's say that's a rough approximation of what this line looks like. If I take an average rate of change over any 2 points and find the change in y over the change in x, it doesn't matter where those points are. This slope is always going to be 2. And if this hasn't already looked familiar to you, this is really a slope calculation. So basically it does not matter what interval we use for this. As long as those endpoints are different, you're going to be able to calculate a slope of 2. So let's move on to question 2. Now I have a function that's a quadratic, so this is not linear. So I still want to find the average rate of change. So in terms of calculating this is not going to work much differently or really any differently from what we just did. So if I want to find the average rate of change, that's going to equal to g of 13, that's the right end of this interval, minus g of 5 all over 13 minus 5. So this I'm going to need to, I don't know if I'm going to be able to do this by hand. So what is 13 squared? I know that's 169. Plus 2 times 13, that's 26. Minus 8, I get 187. All over, no, not done. 187 minus what happens when I plug in 5. So 25, so 5 squared is 25. Plus 2 times 5 is just 10. So 35 minus 8, that is 27 all over 8. So I get 160 divided by 8, which gives me an average rate of change of 20. So that's part A. For part B, you want to do something a little different. Our interval still starts at 5. But the upper end, the right end of the interval is generic. It is some unknown constant k. So what is that going to do for us in terms of finding average rate of change? And the answer is not that much. I still want to find this difference. So what's g of k minus g of 5? So I'm still going to go find the difference between the y values on the right end of the interval compared to the left end of the interval, all over k minus 5. So what happens when I plug in k to this function? I get k squared plus 2k minus 8. Actually, I'm going to move down the lines and run a room, aren't I? This equals k squared plus 2k minus 8 minus whatever happens when I plug in 5, which we've already done that, so might as well use it. That is 27. All over k minus 5. Let's see if we can simplify a little bit here. So I get k squared plus 2k minus 35 over k minus 5. I'm guessing that many of you stopped here, which is fine. But one thing I will point out here is you can factor, and let's see if anything happens. So how do we factor things that look like this? K squared plus 2k minus 35. So if I can find some numbers that multiply together to give me negative 35 and add together to give me positive 2, I can factor this. So I believe that's going to give me k minus 5, k plus 7, and then all over k minus 5. What does this give me? This gives me a final expression of k plus 7. Like I said, if you didn't go that far, that's okay. But I wanted to show you that there's a little more simplification that can happen. So part C, find the average rate of change of g over the interval 525 using your answer from part B. So here's what we have here is that we came up with an expression. If I want to find the average rate of change on this function over any interval starting from 5, I can kind of do that with this thing I just did here. So what is my final value of x on that interval? So my average rate of change will be equal to 25 plus 7, which is going to equal to 32. So basically in part B, we built a shortcut for this. So for the homework here, I asked you to confirm your answer by calculation, which I'm basically, if you use the same scheme we did in part B, you will get an answer of 32. But for now, I'm just going to rely on the formula we used. All right, question 3. I want to find average rate of change, but now I'm looking at a graph. So find the average rate of change of f over the interval 0, 9. So this is probably going to look familiar, but how do we do that? We can actually zoom in. We can use the same scheme that we did before. What's the average rate of change? That's equal to f of 9 minus f of 0 over 9 minus 0. And now I have to read f of 9 from the graph. F of 9 is this point here. Looks like 3. What's f of 0? That looks like negative 7 over 9. Just confirm, let's get 3 minus negative 7 over 9. That gives me an average rate of change or a slope of 10/9. B asks us for a similar calculation over a different interval. So what is f of 5 minus f of 2 over 5 minus 2? Now, same sort of thing. I'm going to erase these. I'm going to find these points again. When x is equal to 5, what is y equal to? That looks like 1, or sorry, negative 1. When x is equal to 2, what's y equal to? That looks like negative 3. So negative and over 5 minus 2, which is 3. What is negative 1 minus negative 3? That is 2. So final result here, average rate of change is 2/3. Part C, this question asks us to go in kind of an opposite direction. I want to find an interval over which the average rate of change is equal to 0. So now I'm giving you an average rate of change, and I want you to give me an interval where that's going to happen. So what does it mean for the average rate of change to be equal to 0? Well, that means that f of b minus f of a over b minus a is equal to 0. What can we learn from that? So that's basically the calculation. When is something divided by something else going to give you a 0? That really only happens if the numerator here is equal to 0. So what does that mean? If f of b minus f of a is equal to 0, well, then I can solve, or I can kind of rearrange some things and get this. F of b equals f of a. So really, the average rate of change is going to be 0 on any interval where f of b, or basically the y values across the endpoints of the interval, are going to be identical. So there's probably an infinite number of correct answers here, but let's pick this one. So at this point here, I believe it has the same y value at this point here. So what are those x values? So the y values are both 5, which means if I find the slope or the average rate of change from that left point to that right point, it's going to be a horizontal line, and that has a slope of 0. So what are those x values there? It looks like one such interval would be -4 to, it's like 10. And just to illustrate that there are many answers here, what if I go back a point? It looks like the y value there is also 5. So I think I can even say -5, 10. So again, many of you are going to have answers that are correct, but they are not -4, 10, and that's fine. Lots of options here.